Hello there and welcome to Lower 6th Further Maths A-Level Pure Core 1 past paper, June 2013. Here we're looking at question 5, which is a brand new question to the syllabus, so I've added this question in myself. What we're looking at to do for part A is to find the matrix P, and it represents a reflection over the line of x equals 0. So what we're going to do first is set up our axes, and we'll start by looking at x and y, and then we'll think about what will happen to z later on. But what's going to happen here is we're going to have a reflection over the line of x equals 0. So let's start with the coordinate for 1, 0. If we reflect on the line x equals 0, now that line is the vertical line for the y-axis. That's going to reflect over to the left-hand side at -1, 0. The coordinate for 0, 1 is when it's reflected over that y-axis is actually going to stay exactly where it is. This is going to happen exactly the same for the z-axis as well. So we don't need to draw out any other diagrams for that. That's going to stay exactly where it is. So what you can see happening here is the y and the z variable are going to stay exactly where they are. The x variable is going to be reflected over the x equals 0 line, so that's now at a negative. Fill in the rest of the cells with zeros and you get your value, you get your matrix P. The Q1, that's a bit more challenging, it's more marks for it as well. It is to rotate 90 degrees around the z-axis. So seeing as the z-axis is going to be remaining constant, I need my y and my x variables here. So let's see what happens to a couple of coordinates. The coordinate 1, 0, when we're rotated 90 degrees anti-clockwise, will move from the right-hand axis upwards. So we'll end up here. And the coordinate for 0, 1 will end up on the left-hand side at -1, 0. So if we're thinking about here what we're doing in 2 dimensions, we're using matrix Q to transform the coordinates 1, 0, 0, 1 to the set of coordinates 0, 1, -1, 0. Now this is for the x and the y variables, and so what we can get here is for the 2 by 2's, Q times the identity is this one here, so Q must equal 0, -1, 1, 0. But that's in 2 dimensions. We're looking for it to be in 3 dimensions. So what we do here is we transform this matrix here into a 3 by 3, and we keep z exactly where it is. So this matrix here has come straight in from the 2 by 2, and every other cell has just been filled in with either a 0 or 1. 1 in the bottom right, because that's where the z variable goes. Okay, so moving on to the next part. Part C looks for us to write out a matrix M that is a reflection in the x equals 0 line and then an anti-clockwise rotation 90 degrees around the z-axis. So what we have to do in this case here is if we want to do P and then Q, and then that will get us to our answer. What we have to do is we have to multiply them in the reverse order. So what we're going to get here for Q, that was 0, 1, -1, 0, and then zeros and ones. P was -1, 0, 0, 1, 1 there, 0, 0, 0. So let's multiply these 2 matrices. I can do this on my calculator. The examiner isn't really going to be able to tell by this. So enter your first matrix. That's going to be matrix A, which will be this second one here. That was the first matrix P that we discovered. The next one, we're going to start a new matrix, and that will be matrix B, and we'll define that. So you go into defining matrices using the option button. In the top left, you click define your matrix and then enter the dimensions of it. The next thing you need to do is then multiply them in reverse order. Now you recall the matrices by clicking on the options button and then hitting either the 3 or the 4 button depending upon which matrix you want to recall. Press enter and you get your answer, and we'll recall that off. 0, minus 1, 0, minus 1, 0, 0, 0, 0, 1. The examiner will never know that I used my calculator there. Okay, part D, use your calculator to define m minus 1 and give a geometric interpretation of that matrix. So what I have to do here is I have to now go into my options button and define a new matrix, matrix C. That is this matrix here, this is M. And then recall the matrix C, inverse it by using the power of -1 button there, and write down your answer. So m minus 1 is 0, minus 1, 0, minus 1, 0, 0, 0, 0, 1. That's exactly the same as the matrix M. Give a geometrical interpretation. So what's going to happen here is if the first thing I did for my matrix M was to reflect, and then I rotated, then for this matrix M minus 1, it's going to be a rotation first going in the reverse order, so that's the inverse, and then I'm going to reflect second. So this matrix M minus 1 represents a clockwise, because it's the reverse, rotation 90 degrees around the z-axis, and then a reflection in the plane of x equals 0. So do you see there I've done the reverse order for my transformations, and I've also had to reverse the operation as well. So where I rotated anti-clockwise in my matrices for Q, for P I mean, for Q actually, I have to rotate it clockwise to reverse that transformation. The same with the reflection. The opposite of a reflection is a backward reflection, which is exactly the same. So I have exactly the same thing there. Great, so 8 marks for that.